Fourth grade lesson 5.2 is factors and divisibility, like whether something is able to be divided by a specific factor. Let's have a look at how this plays out. Our essential question is, how can you tell whether one number is a factor of another number? Remember, a factor is a number that can be multiplied together with another number to make a product. So we are given this problem. Students in Carlos' art class painted 32 square tiles for a mosaic. This is a mosaic here. They're decorative patterns made with pieces of glass or other materials. They will arrange the tiles to make a rectangle. Can the rectangle have 32 tiles arranged into 3 equal rows without gaps or overlaps? So one way we can determine that is we can draw a model. So let's go back and look at the problem again. They're doing 32 square tiles, and they're going to arrange the tiles to make the rectangle. We need it to be a rectangle, and we're doing that with 3 equal rows. So I'll go ahead and draw out my 3. I need a different color there. Okay, here we go. 1, 2, 3 rows. And remember, I want to keep it a rectangle. So I'm moving along here. That would be 3, then 6, 9, 12, 15, 17, 18, 21, 24, 27, 30, and I'm trying to get to 32. I would have to do that, right? If I only had 3 rows. If I had 3 rows here. If you weren't sure why I was counting by 3s, I drew that over, and so if it was 3 times 1, that was going to be 3. I went another 2. 3 times 2 is going to be 6. If I went 3 over, then I have 3 times 3, which is going to be 9. That's why I was counting by 3s. I got over here to 30, but in order to make this rectangle be a rectangle, I needed to be 33. So I cannot do 3 as a factor for 32. I've just discovered that. The only way it's a factor is if the whole thing made a rectangle. So a rectangle cannot have 32 tiles arranged into 3 equal rows and still be a rectangle. We get all goofy there. So that is one way we can determine, 3 is not a factor of 32. Nothing times 3 is going to land exactly on 32. There's another way, and I'm going to pull something into here real quick. Let me grab it. Because some of you are still using the chart, and that's fine until, we get it all memorized. For now, use the chart to help you out. If 3 is a factor of 32, then the unknown factor in 3 times some number that we don't know yet will equal 32 as a whole number. So they have 32 divided by 3 here, right? Because that's the inverse of multiplication. So 32 divided by 3 will give us that number. We can go down the 3 row until we get to 32. And we need, if it's going to be a factor, it will land exactly on 32. It's not going to be as close as possible without going over. This time it's going to be exactly, if it's a factor of 32, it must land exactly on 32. So let's see. No. 3 is not a factor of 32. The closest we can get is 30, which is times 10. But that leaves us with 2 left over, as we saw up here. So the unknown factor in 3 times blank equals 32 is not a whole number. We ended up with remainders. Those end up becoming fractions or decimals later as we get further into our math, but it's not a whole number. So the rectangle cannot have 32 tiles arranged in 3 rows. How can I tell whether 4 is a factor of 30? Well, I could try and draw 4. That's one way to do it. So you could answer that. Or I could go down the row of 4 and see if it lands on 30 exactly. And no, it doesn't. It's not a factor of 30. Had they asked me if it was a factor of 32, then I would have said yes. Because if I go down the 4 row, 4 times 8 is 32. That means 4 and 8 are factors of 32. So what you'll find in these patterns of numbers as you go along, that there's some really handy divisibility rules about whether a number is divisible by another number or whether a number is a factor of a product. And these rules make it really simple to find. And they're useful because as we build on this knowledge, it will help you with things like LCM, lowest common multiple, and greatest common factor, and even into some trickier things that you will see as you go up into the middle school grades. So recognizing these rules and keeping them in mind will be helpful. You might want to grab a Post-it note from me and stick it to this page because you'll probably refer back to this page until it gets kind of stuck in your head. So here's some divisibility rules. A number is divisible, able to be divided by another number if the quotient is a counting number and the remainder is 0, meaning there's nothing left over. You land exactly on that number, right? Some numbers have a divisibility rule that you can use to check and say, oh, is this number divisible by that? Let me see. You can use a divisibility rule to tell whether one number is a factor of another. So is 6 a factor of 72? Well, before we get to that, let me go through these divisibility rules. The number 2. This number is even. So since it is an even number, so if you count by 2, you go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on, right? Well, let's write those out and then let's take notice of the last number in each of those numbers. 2, 4, 6, 8, and so on. I've gone ahead and written them out for you. 2, 4, 6, 8, 10, 12, 14, 16, blah, blah, blah. I then went ahead and underlined the last digit in each of those numbers so you could see this pattern that happens. We have 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. So you could remember that 2 will divide evenly into any number that ends with a 2, 4, 6, 8, 0. In fact, you might want to write that on that page right there. Maybe put the word ends in front of it. Ends in. Those are even numbers, and 2 can divide equally into any even number. So 2 is a factor of any even number, and an even number is a number that ends in 2, 4, 6, 8, or 0. So if you look at a number like 72, for example, it ends in a 2. So if I asked you, is 2 a factor of 72? You could say, yes, it is, without even calculating, because it's even. It ends in a 2. Let's look at the next one. And this one to me is way cool. I really like this one, but that's probably because I didn't know about it until I was an adult. I didn't know about this divisibility rule, so I was always just testing out 3 times with this and 3 times that and trying to figure out if it was in fact a factor. I didn't know about this divisibility rule, but it's pretty cool. So it doesn't make a lot of sense when you read it, but I'll show you. So 3 will be a factor of any number where the sum of its digits is divisible by 3. Let me show you what they mean by that. So if I have the number 12, oopsie again, here we go. I got it this time. I got it, guys. I have the number 12, and I'm wondering, oh, is 3 a factor of that? Now, a lot of you are probably in your head going, well, yeah, 3 times 4 is 12. I already know that. But just bear with me here. If you add the sum of the digits, so we have the digit 1 and the digit 2, and remember sum, spelled like that, means addition. So if I add 1 plus 2, I get 3. Is 3 able to divide into 3? Yeah, 3 times 1 is 3, so it's a factor. That was kind of an easy one. What if I did 42 and I asked you, is 3 a factor of 42? Okay, well, let's check. Using this divisibility rule, I'm going to add together the 2 digits. 4 plus 2 is 6. Is 6 divisible by 3? Or is 3 a factor of 6? Yeah, because 3 times 2 is 6. So if 3 times 2 equals 6, which is the sum of these two numbers, then 3 times something equals 42. And it just works that way. So that's really a helpful one. So that's how you could always check to see, hey, is this number divisible by 3? Instead of having to divide by 3 to check it, you can just add those 2 digits together, or 3 digits if it's a larger number, or 4 digits if it's a big, big number. It works for those too. Cool rule. So that tells you that 3 would divide evenly into 42 with no remainder. So that your brain has the proof, I'll go ahead and do that real quick. 3 divides into 4 one time, and 3 divides into 12 4 times. It's 3 times 14 that gives us 42. But I didn't have to divide it to find out if 3 was a factor or not, right? Because now I know this handy-dandy rule. 5 is a pretty easy one. I think you already know this one. Any number that ends in 0 or 5 is divisible by 5. And you know that because you count by 5s pretty easily. 5, 10, 15, 20, 25, 30, 35, 40. All of those numbers have the last digit, the ending, in a 5 or a 0. So if you have a number like 40, and I'm asking you if 5 is a factor of that or if it's divisible by 5, you can say, yeah, because it ends in 0. 6. This one I'm just learning with you right now because I didn't know about this one, but it makes sense because if you take that knowledge from the 3 and then apply it to the 6, it makes sense. If the number is even and divisible by 3, then 6 will also divide into it. Well, how can I know if it's divisible by 3? Let's go back to the 42 that I talked about. We added the 2 digits together. 4 plus 2 is 6. 6 is divisible by 3. 3 times 2 is 6. So if 6 is divisible by 3, then 42 is also divisible by 3. So yes, on one check, it is divisible by 3. Also, it is an even number. Even numbers end in 2, 4, 6, 8, or 0. So if it's both divisible by 3 and in even numbers, basically you're taking both of these rules, putting them together, and you can find out if it's divisible by 6. Finally, for 9, the sum of the digits is divisible by 9. So this also is a new one to me. If I added them together, 4 plus 2 is 6. That's the sum of the 2 digits. 9 cannot be multiplied by anything to get 6, right? Let's find one that is. Let's do 63. If I add 6 plus 3 together, that is 9, and 9 times 1 does give me 9. So 63 is divisible by 9. Let's find a bigger one. What about 108? Is that divisible by 9? Is 9 a factor of 108? I don't know. Well, let me add up all 3 of my digits together. 1 plus 0 is 1, and 1 plus 8 is 9, and 9 is a factor of 9 because 1 times 9 is 9. So there are some divisibility rules that will save you a little bit of time in having to divide to check it. You can use those rules to kind of do a quick check and see if it works. Okay, here we are now. Now that we've gone through them, is 6 a factor of 72? Well, okay, it is even, so check on that one. That's fine. Is it divisible by 3? Remember, we add the sum of the digits together. 7 plus 2 is 9. And 3 can divide into 9 equally. 3 times 3 is 9. So this number is both divisible by 3 and it is even, so it must be divisible by 6. So here is 72 even. Yes, yes it is. What is the sum of the digits? 7 plus 2 equals 9. Is the sum of the digits divisible by 3? Why, yes, yes it is, because 3 times 3 equals 9. 72 is in fact divisible by 6 because it met both of the criteria. It's even and it's divisible by 3. Okay, so we'll do the try this. They want us to list all of the possible factor pairs for 72 in the table. I went ahead and wrote it the way I tend to do it as well, and I put the divisibility rules here. And now you'll see how those are useful to you if you have to find the factors of these numbers. So we already know 1 times 72 is going to equal 72, so 1 and 72 are factors of 72. We knew that. Is 2 a factor of 72. That's where I always go to next. And I know that if the number is even, meaning if it ends in 0, 2, 4, 6, or 8, then 2 will divide evenly into it. I don't know how many times, but I know it will. And it is, in fact, an even number. 72 is an even number. It ends in a 2. So, yeah, 2 is a factor of 72. Well, I know it is. Now I just have to do the calculation to find out. So let's do 72 divided by 2 so that we can find out 2 times what number gives me 72. Remember, multiplication and division are inverse of each other. So if I want to know 2 times what number gives me 72, I can do the inverse of multiplication and take this 72 and divide it into 2 equal pieces, and it will tell me. Okay, let's use the skills we learned in the last chapter. We're starting in the tens place first. 7 only, ignore the 2. What number, 2 multiplied by what number gets me as close as possible to 7 without going over? Yeah, that's 2 times 3. And 2 times 3 gives me 6. 7 minus 6 is 1. And bring down the 2. 2 times what number gives me 12? And notice I didn't say gets as close as possible without going over because we know it's not going to go over. We know it's going to be right on. Well, 2 times 6 is 12. So the other factor is 36. 2 times 36 equals 72. So the factors 2 and 36 are a factor pair. My next one would be, what about 3? Is 3 a factor? Because I would put 3 here if it's a factor. Well, is it divisible by 3? The sum of the digits is divisible by 3. We have 72, so we're going to add those 2 digits, the 7 and the 2 together. 7 plus 2 is 9. And 3 can divide into 9 equally because 3 times 3 equals 9. So, yes, 72 is in fact divisible by 3. And so now I just need to calculate what it would take to get 3 times what number. Again, 3 times what number is going to give me 72. I'll use the inverse or opposite operation of multiply. 72 divided by 3, and that'll help me solve that problem. 72 divided by 3. I'm looking at the tens digit only, the 7. 3 times what number gets me as close to 7 as possible without going over? 3 times 2 does that, because 3 times 2 is 6. There will be 1 left over. Bring down the 2. And 3 times what number gives me 12? 3 times 4 gives me 12. Okay, so that other factor, the one that was missing over here, is 24. So let's go ahead and write that in. 3 times 24 equals 72. Factors are 3 and 24. Now see all the steps that I'm taking to find out where I have to calculate to find out the other factor. Imagine doing that and then finding out it wasn't a factor. That's what you would have to do if you didn't know these divisibility rules. You'd be like, I don't know, I'll try it. I don't know, I'll try it. But if we can eliminate some of them with these divisibility rules, that's super helpful. 4 would be my next factor I would want to test out. 4 would be my next one. I'm going to put it here for now. But I don't know if 4 goes into 72 equally. I'm not sure. And there isn't a divisibility rule for it. So this is one example of where I'm just going to have to calculate it to find out. And if there's something left over, then no, it isn't a factor. So here we go. 4 times 1 is 4. I subtract and get 3 left over. Yes, this number is less than my divisor, so I can keep going. And 4 times 8 is 32. So that is exactly right with none left over. So yes, 4 is a factor of 32, but we didn't know that right out the bat. We didn't know that because of divisibility rules, so we had to do the math. We might have gotten it to be dead on, and then it could have been that we didn't. So we'll write it down here now, 4 and 18. Okay, what about 5? Is 72 divisible by 5? No, right away, I don't have to do that calculation. I just don't. Because 72 does not end in a 0 or a 5, right? It has to end in a 0 or 5. So not divisible by 5, so we can skip 5. Is 72 divisible by 6? Is 6 a factor? Well, it is an even number, ends in 2, And we already know it's divisible by 3 because 3 is a factor. So yes, it is. 6 is in fact a factor. We just need to find out real quick what multiplies by it. So we'll do the math, but we know it's going to work. 7 is what I'm using right now. 6 times 1 is 7. That's as close. I'm sorry, 6 times 1 is not 7. 6 times 1 is 6. That's as close as I can get. And then bring down that 2. And 6 times 2 is 12. So 12 is its pair, is its factor. We'll put that here. What about 7? I would have to explore that. 72. I already actually can see it because 7 times 1 is 7. And I had 0 left over. Bring down the 2. 7, nothing times 7 is going to give me 2. It's going to end up being a remainder. So I would have that and then a remainder of 2. So no remainders when it's talking about whether it's a factor or not. No remainders allowed. Now we're getting into the numbers that we already know are factors of 72. We're climbing up there. There's a lot of factors for 72. So the next one I would be counting, so 7's out. The next one I would be looking at is 8. 8 is the next number. Okay, but thankfully I know my multiplication facts, or I can use my chart. 8 times 9. Hopefully by now you are starting to recognize that 8 times 9 is 72. See how handy that is to have in your brain? Then you don't have to calculate anything out. Right away I knew that. My factors are 8 and 9. On my T-chart it looks like this. And now I don't need to check for after 8. There's 8. I don't need, that's not 8. There's 8. I don't have to check after 8 because it's already there. 9. 9's the next number, right? So I'm done. That's all of them. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72 are all of the factors of 72. How did you check if 7 is a factor of 72? We just calculated it, right? Where did we do that one? Over here. We just calculated it because we didn't have a nice handy-dandy rule to tell us whether it was a factor or not. Okay, so we're on the Sharon Show, and here's question number 1. Is 4 a factor of 28? Now, if you're getting comfortable with what factors mean, what we're asking you is 4 times what number will give me 28? Will a number give it 28? And so if you have your math facts memorized, your brain probably went, pop, there it is, I know what it is. If you're still working on it, it's no worries. You'll get it, and you can use a grid to help too. But they want us to draw this model. So we're going to make a rectangle with 28 squares and 4 equal rows. So we have 1, 2, 3, 4. So 4 rows. If I just went once over, that would include 4 units, right? So there's 4. Well, I want to get to 28. So if I went twice over, that's 4 and 8. Keep going. I want to get to 28. 3 times over, that's 4, 8, 12. I want 28. Keep on going. 16, 20, 24, 25, 26, 27, 28. Perfectly. And it took us 7 columns to do that because 4 times 7 equals 28. So 4 is a factor of 28. We don't have a divisibility rule on 4, so we went ahead and calculated that out. But you guys know that, most of you know that 4 times 7 is 28. Those of you who don't yet, that's okay. You're still working on it, and I know you're working hard at it. All right, and so for numbers 2 through 5 in our Sharon Show, they just want us to write yes or no on whether 5 is a factor of any of these numbers. So let's go to that divisibility rule for 5. If the last digit of that number ends in a 0 or a 5, then yes, it is divisible by 5. If it does not, then no, it is not divisible by 5. So 27, its last digit is a 7, not a 0, not a 5. No, 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 not divisible by 5. 30 ends in 0, divisible by 5, so yes. 36 ends in a 6, that's not a 0, that's not a 5, so it is not divisible by 5. And 53, that ends in a 3, not a 0, not a 5, so it is not divisible by 5. And so how easily we could do that without calculating anything, because we had the use of these divisibility rules. On your own, if you go on to that, is going to ask you the same questions for numbers 6 through 9, but now we want it to be the divisibility by 9 is a factor. Is 9 a factor of? So you would have to add those digits together and ask yourself, is the sum of those digits divisible by 9? Anyways, I think you get it. We can clarify more if it's needed, but I think you'll be okay to go on Think Central. You let me know if you need me to explain further in class.